Our lesson today will capture one of the many systems of the human body. We have the breathing system as the theme of the topic of our discussion today. As we understood in the previous topics, the human body comprises of several other systems, namely the reproductive system, as I mentioned, and we agreed that the reproductive system is a system that involves the reproduction in the body of a human being. That is, by the use of the male and the female sex cells. We also talked about the digestive system, whereby we discussed on how food is taken into the body, broken into particles that the body can use for metabolic systems or metabolic processes, as we discussed. Today, however, we are going to talk about the breathing system and what it entails. You can see on my chart the diagram of a human being, partially, not fully, and then different parts that are involved in taking in air and taking out the same. The parts that we're going to talk much about include the nasal cavity, the trachea, the bronchus, that is the right and the left, the subdivision of the bronchus called the bronchiole. Then we shall talk about the lungs. We shall include the rib cages, as indicated there. Then we shall also talk about the diaphragm. To start us off, the breathing system involves taking in air. And so, what is air? Air, as was studied in the previous classes, is a mixture of gases. And the gases that are involved in the air that we breathe in and out include 1. Oxygen, carbon dioxide, nitrogen, water vapor, and a few other environmental particles of dust that can be taken in, though they don't form part of air. The two parts of air that we are likely to talk about in the breathing system are oxygen and carbon dioxide. But first, through which path is air taken in and out of the body? Air is breathed in through the nasal cavity. A cavity is simply a canal or a pipe along which air, in this case, passes into the body. The epiglottis is not part of the breathing system and therefore is not discussed during this lesson, but then later we shall find out what it does in the human body. From the nasal cavity, air is taken into the trachea or windpipe. The windpipe or the trachea further subdivides into the bronchus to the right and the bronchus to the left. The bronchus are just but a subdivision of the larger pipe, that is the trachea we saw initially, that further subdivides into the smallest units of the former trachea, that is called the bronchiole. Then the bronchioles empty their contents, in this case air, into the small sacs that are called the alveoli or the air sacs. Now, what is the function of the different segments of the breathing system? 1. The function of the nasal cavity is to put in air or to bring in air into the body of a human being. The air that is taken into the body of a human being is 100% air. That is, a section of it, oxygen, like we learned previously, oxygen is 21%. A section of it, carbon dioxide, like we had learned initially as well, 0.03%. A section of it, water vapor, that is 1%. And a section of it being rare gases, that is 1% as well. All that 100% is taken into the body of the human being through the nasal cavity. So what happens in the nasal cavity? The nasal cavity has the function of, one, making the air warm. The air that is to be taken into the body of a human being needs to be warm, because a human being is a mammal and all mammals have constant body temperatures. So everything that is entered into the body is made warm at a given point, so that the temperature of that air is equitable or equal to the temperature of the human body. So the nasal cavity makes the air warm. Two, the nasal cavity has small hairs which are called cilia, C-I-L-I-A. The cilia's function, or the small hairs in the nasal cavity, are meant to trap dust. When we breathe in, like I mentioned initially, that occasionally we breathe in dust particles, and our body does not want dust particles. So what happens is that the nasal cavity has the air that eventually traps dust, so that the dust is not breathed into the system. The air that goes down is warm and clean. Then finally, we have the mucous glands inside the nasal cavity. Their function is to produce, one, mucus that will also help with the trapping the dust and germs, yes, and also to make the air breathed in moist. The human body is adapted to taking in air in moisture form, not dry air. So that air is made moist in the nasal cavity. So like I mentioned, the nasal cavity has four major functions. One, to direct air in. Two, to clean the air by the help of cilia, which are the hair structures in the nose. Three, to make the air moist using the mucus. And four, to warm the air because of the constant body temperature. From the nasal cavity, air is taken down to the trachea, also known as the windpipe. As the name suggests, the trachea is just but a pipe. There is no breathing process that takes place in it. It simply allows air downwards. Just like the nasal cavity, the cilia present in the nose are also present in the trachea, but in small sizes. So that in case any foreign body passes through the nose, it will be trapped in the trachea and brought back by muscles of the trachea. The trachea has got rings, as you can see it. The rings, which are muscular. The muscular rings are meant to help keep the trachea open, so that at any point, whether breathing in or out, it is not closed. Then the trachea subdivides into the subdivisions known as the bronchioles, the bronchus. That is the one to the right called the right bronchus, and the subdivision to the left called the left bronchus. Also, like the trachea, the bronchus are just but pipes that bring air to the smallest subdivisions of the bronchus called the bronchioles. Then finally, bronchioles, being the smallest pipes, are now connected to the small bags of the lungs called the alveoli or the air sacs. Now, every air sac has a network of blood capillaries. The blood capillaries are the ones that will now take in oxygen and supply to the rest of the body, and also take carbon dioxide, which the body does not require, back from the body, feeds it to the alveolus, and then it is breathed out through the nose. Then, as you can see in our diagram, we also have the left lung and the right lung. The lungs in this case are accommodating sacs. They only accommodate the air sacs, meaning the air sacs have to be in a bag. So when we breathe in, the bag gets bigger. That is the lungs. When we breathe out, then the content here is deflated. Then the bag becomes small. When you come down, you will realize we are at the diaphragm. This line represents the diaphragm. A muscle, a muscular membrane that separates the chest from the abdomen. Its main function is to separate the chest from the abdomen, so that when the lungs swell, they find a protective device that they don't overswell and come down. The diaphragm, just like the lungs, also may move upwards or downwards. When we breathe in, the lungs enlarge and the diaphragm is forced to move down to offer a larger surface area. And when we breathe out, the diaphragm helps to push the air outside by reducing the volume of the chest cavity, thus enabling breathing out easier. And as at our level, breathing in is called inhalation, while breathing out is called exhalation. So whenever we exhale, the diaphragm comes up, the lungs contract, that is, they become smaller, and air gets out of the body through the nasal cavity when we breathe out. In the contrary, when we breathe in, a lot of air is accommodated in, the bag, that is the lung, swells, pushing the diaphragm downwards to enlarge the chest cavity, the space in the chest. Remember, along the other sides of the lungs, we have the rib cages. The ribs, structures of bones or bone-like structures that are meant to provide security onto the other side of the lungs, so that one, it does not overswell, and two, it also offers protection from the east and from the west. Whenever we breathe in, the lungs, like I said, expand, and when we breathe out, they contract. And because next to the lungs is the rib cage, the expansion and contraction of the lungs may cause a rubbing between the lungs and the ribs. And that rubbing may cause friction, a force that can create heat onto the surfaces of the lungs. That force, if not controlled, can cause wounds or can cause burning, because friction causes heat. To prevent that burning, there is always a natural membrane of flesh between the lungs and the ribs, which acts as a lubricator, so that the lungs and the ribs don't rub directly. That kind of membrane which is between the ribs and the lungs is called pleural membrane. Pleural membrane. Then finally, the whole process, remember we said, takes in 100% air. That is 21% oxygen and 0.03% carbon dioxide. But when we breathe out, a lot of oxygen breathed in is used up in the body. So little oxygen compared to the one breathed in is breathed out. When we breathe in 21%, out, we now breathe 16%. And when we breathe in 0.03% carbon dioxide, out, we breathe 4%. Meaning, about 5% of carbon dioxide is manufactured in the body, and about 4% of oxygen is used up during the process of respiration. Up to there, you all realize that breathing in and out is very necessary, because it is the air we breathe in that will support the life, starting from the body in the breathing system and the rest of the other systems that we studied earlier. And on that note, we come to the end of today's lesson.